63. Two curves C1 and C2 are defined for all values of x and have respective equations. y1 is equals to 7 raised to power x and y2 is equals to 2 times 5 raised to power x. Then you've been told to show that the x coordinate of the point of intersection of the two curves is given by 1 over log 7 to base 2 minus log 5 to base 2. So the first thing you need to know, at the point of intersection, the two curves are equal, isn't it? Are we together? So at the point of intersection, the first curve is equals to the second curve. That means they are sharing that same point, meaning they are equal at that point, isn't it? So y1 will be given is 7 raised to power x, isn't it? To be equals to y2, which is 2 times 5 raised to power x. Now for you to get, you'll be told to show that the x coordinate is given by this equation, meaning we want to make x the subject of the formula, isn't it? We want to make x the subject of the formula. So for you to get x the subject of the formula, any term with x you bring on this side of the equation, isn't it? So we divide both sides of the equation by 5 raised to power. Are we together? 5 raised to power x. So what do we have? We have 7 raised to power x over 5 raised to power x is equals to 2. Are we together? So for us to remove x in the power, we introduce log on both sides of the equation, isn't it? We introduce log on both sides of the equation. So you introduce log. But you can see the log we have in this problem is log 2 base 2. Are you seeing? So what do? We introduce log 2 base 2. When you introduce log, it means you introduce log 2 base 10. Then common log is when the base is silent, isn't it? But here you can see our problem is having log 2 base 2, meaning we introduce log 2 base 2 on both sides of the equation, isn't it? So after introducing log 2 base 2, what do? A log going inside, division changes to subtraction, isn't it? So we are going to have log 2 base 2 of 7x, then division changes to subtraction, then log 2 base 2 of 5x is equals to log 2 base 2, a log of a number to the same base is 1. Are we together? So from here the power becomes the coefficient, isn't it? The power becomes, so here it means we have x log 7 to base 2 minus, here we have x log 5 to base 2 to be equals to, so x is a common factor, we can factorize out a common factor, isn't it? So if you factorize out x, we get log 7 to base 2 minus log 5 to base 2 is equals to 1. So for us to get x, we divide both sides by log 7 to base 2 minus log 5 to base 2. So what do we get x to be? 1 over log 7 to base 2 minus log 5 to base 2. We divide both sides by the coefficient of x for us to remain with x, isn't it? And you see what we found is exactly the x coordinate. Are we together? So the x coordinate is given by 1 over log 7 to base 2 minus log 5 to base 2. Is that understood? Yes. Good.